we're going to talk about vectors in the plane. Shh, listen. A vector itself is represented by an arrow, and you can see that on the screen. Okay, the vector, if you've ever watched the news or the Weather Channel, when they're talking about like a hurricane or some massive storm front coming through, if you watch it long enough and you don't fall asleep, they'll eventually come to a vector field. They'll eventually show this picture of all these little arrows pointing in the way that the wind direction is going. And what you'll notice is that the arrows have a certain direction they're pointing in, which is showing you the way the wind is blowing at that point around in the cloud. And the arrows have different lengths depending on where they are around that cloud. The length of the arrow is considered the strength of the wind, right? The stronger the forces, the faster the wind blows, then the longer the arrow was. So to indicate stronger forces here, weaker forces where the arrows were shorter. Okay? A vector, anybody seen Despicable Me? What does a vector have? Oh, come on. I want to hear it just like the movie. No. All right. It is magnitude and direction. Okay? I don't know. So with our vectors, magnitude is going to be literally the length of our vector here. It's the length of the arrow that we're going to draw. The direction is what you think of. Going back to the unit circle, no, you don't have to know the unit circle, but it will definitely be a plus. If we're going to be talking about theta, then theta goes right there. The angle that theta makes from the horizontal all the way up to wherever my vector is the direction. So if I told you that you have a vector in the direction of 120 degrees, you would literally turn to 120 and your arrow goes out that direction. If I said 350 degrees, you would turn to 350 and go that direction. I could say angles outside of 0 to 360, but that's kind of irrelevant. It's redundant. I don't need to. I just need to know where to point the arrow and how long to draw the arrow. So giving you an angle that's beyond 0 or 360 is just not done. I mean, you could, but there's no point. I'm not going to do it to you. So what I want to talk about first is how to look at this arrow. So if we kind of go in here, we talk about the arrow, what we're going to see is a specific length, but there's parts I want to look at. So what we're going to look at is this piece. This is our X. And we have the part over here. And this is your Y. So X and Y are components inside this vector. X represents the horizontal vector, component of the vector. Y represents the vertical part of the vector. So if I told you where to start and where to end, you could also tell me, well, if you start here, go this far over and this far up, that'll get you to the same place. It's kind of like a right triangle, right? I could go in here and I could draw in a little right triangle here, and I could use that idea to find all the different pieces of that triangle, right? We know even now, even if it wasn't a right triangle, I have the law of sines and the law of cosines that I could fall back on and still find all the pieces of the triangle. Okay? So in some of our word problems, that's how it will start.
Is that supposed to be a Q or a theta?
It's a theta. Okay? So, yes.
Written in red on the...
I'm getting there. This piece right here, it's sitting on the angle, so it's V. It's vector V. The symbol at the top, that's more like a half of an arrow. So the top half of the arrow, that's the symbol we use for vectors. Okay, so just get used to writing it that way. Magnitude is literally what you think of. If I were going to find the length of that red vector, how would I do it? The Pythagorean theorem sounds fantastic. Since it's the simplest form of it, let's just call that the magnitude formula. And so we'll start it off, and the symbol for magnitude is written the absolute value of vector v. So that's going to be equal to the square root of, and I'll show you what a and b are in a minute. A squared plus b squared. In a minute, a is x and y is b, but we'll get there in a minute. Shh, listen. When you go back and watch the video, see how long it takes me to say this twice. Okay? Or 3 times if it happens again because one of you isn't listening now. The symbol above the V is the symbol for a vector. It's a half of an arrow. So just the top half of an arrow. It has one tip, like on the tip of the arrow, instead of 2 tips, it has 1 tip. It doesn't have to make sense. That's just what the symbol is. Okay? So, direction. Can somebody tell me how to find theta up there? Shh. Ha ha ha. What's the formula for theta? If I were given the triangle, if I knew x and y, how could I find the angle that exists right there where theta is? Not sine inverse, because I don't have a hypotenuse. Tangent inverse. Now, don't get me wrong. You could find all the parts of your triangle first, like find the hypotenuse, find the magnitude, and then you could use any trig function you wanted to find the angle. But what I'm going to write out here is the direction is based on just the vector itself. So if I just wanted to go straight from the beginning to the angle, this is what we would do. We'd say tangent inverse of b over a. And I'll get to b and a in just a minute. But like I said earlier, a is x, b is y. Any questions on magnitude or direction? And you'll get questions like, what is the magnitude and direction of the following vector? Just basic stuff like that.
Are you not to write the arrow thing?
Absolutely. There's a lot of notation that you just need to accept. Is it really that hard?
No.
I mean, you just draw it. Just draw a line and then go up. Or, you know. True. Whatever. Line. Just get used to it. It's real simple. I want to talk about the other half of the screen. It says vectors from 2 points. This is kind of where we start. Okay? So, just to kind of go back to the first part, if you write out the coordinates for that first vector on this side over here, so we go back and look at this vector, I'm going to write out, what's the point that it terminates on? What's the point up here? It's 3, 4. 1, 2, 3. No, I'm sorry. It's 4, 3. So it's 4, 3. Yeah, I did it backwards last period. Okay? So I have the vector. I have a point. It starts at 0, 0, and it goes to the point 4, 3. What's the magnitude of this vector? It is 5, a 3, 4, 5 right triangle. Okay? So that's the vector. Well, we'll hold off on that. Let's go over here to what you see here. I want you to graph on your paper the initial point 2, 1. We're going to call that P. And the terminal point 5, 3. We'll call that Q. -1. I want you to draw that on your paper on a coordinate plane. Okay, we're going to be dealing with lots of things on the coordinate plane in general, so get used to that. Each vector must have an identified beginning and ending. We call that initial point and terminal point. If I tell you the points, I'm also telling you where that vector is on my coordinate plane. If I just gave you the vector by itself in components, you have no idea where it is. It could be in the first quadrant, the fourth quadrant, the third, it could be anywhere. A vector by itself has no position. And I'll make that clearer in just a minute. Okay, but if I tell you the points where it's located, I do have the ability to find it. You're right, it is. Okay, so I'm going to go through this process of finding the vector from 2 points, and this is how you do it. And so we're going to say, we're going to call that vector v, just kind of as common. The vector v is equal to, and notice I'm changing my parentheses to a pointed bracket. Pointed brackets indicate a vector, not a point. Point is about where are you? Oh, you go over 3 on the x and you go up 4 on the y, or wherever you're going. And it tells me where to go. A vector tells me it's the same idea, but it doesn't tell you where it is. So here's how you do it. I'm going to use I'll use x and y to represent these pieces. So it's going to be x2 minus x1, comma, y2 minus y1. That's the formula I use. And the way that we do this is it's always terminal minus initial. It's always terminal minus initial. If you get that backwards, you will get the opposite vector. In other words, it'll be the same length, the same magnitude, but it's going to be going in the opposite direction. That is very important that you don't miss that part.
How do you know which one is x2 and x1?
Terminal, initial. 2s are always terminal. 1s are always initial. First and second points. Makes sense. I start on 1, I go to 2. Correct? So if I actually work this part out, I'll say 5 minus 2, and we'll say, 3 minus negative 1. And so that's easy enough. I get the vector 3 comma 4. So this is almost the same vector as before, right? It's actually not the same, but the numbers are flipped. If you take that apart and you look at it on the coordinate plane, that's 3. That's 4.
Why don't we just do that?
You're not always giving a picture. In fact, you will most likely not be given a picture. You can do that, but draw it by the time that you just simply drew the coordinate plane, your neighbor's already got it done by algebra. So drawing the picture, if it's not already drawn for you, is a little over the top, and you don't need all that. Today is a lot more about the geometry of everything. How to draw it, how to add together, subtract, multiply visually. Tomorrow we'll go into more of the algebra parts of it. Okay? So terminal minus initial to create my vector. So your actual vector looks like this. That's the vector 3, 4. It is not the point. Notice that your picture, right? If you look at your picture here, where's the point 3, 4? So it's 1, 2, 3, up 4. So there's that's really hard. There's the point 3, 4 right there. Has nothing to do with my vector. It says you go from your starting point, you step over 3 spaces, and you go up 4 spaces, and you draw the line between those 2 points. You have the vector that we're talking about. It has a magnitude, and it has a specific direction. The magnitude of this one happens to be exactly... What's the magnitude of that vector? It's 5. It was the same as it was last time, right? And so, what's the direction? So here we have the magnitude of v is equal to 5, because it would be 16 plus 9 to get 25. 25 square root of that gives you that. So if I were to find theta, tan inverse of 4 over 3, what do you have? 57 point or 52 point, what is it? 53? 53 point what? 1 degrees. A little bit more on this. Shh, listen carefully. So over here under direction, let me add a little point. Add 180 if x is negative. If x is negative, you're going to add 180 to whatever angle comes out of that. Otherwise, you're going to get negative angles or angles that are too small. Like, wait a minute, 225 is in the third quadrant. Like, if I draw the vector in the third quadrant and you actually find theta, it's going to say 45 degrees. Like, I know that 45 is in the first quadrant. My vector is clearly drawn in the third. So it's actually 225. If you do inverse tangent, it will only give you a result in the first quadrant or the fourth quadrant. So if x is negative, being on the other side, you have to add 180 to it. If you remember that, direction's easy. Questions? All right, next part. We're going to talk about the geometric, like, what do we do if I were to add or subtract or multiply with vectors like this? So what I want you to do on your paper is to attempt to draw exactly what I'm about to draw. It's not hard. I'm going to draw 3 vectors. We'll call this vector u. That's vector v. And then maybe one vector that looks like this. We'll call that w. 3 vectors. One vertical, one horizontal, and one at a 45-degree angle. As he did that, so it's easy to think about. What we're going to talk about is just the basics of, what if I said u, vector u, plus vector v? How would I add these vectors together? You don't have any numbers at all. You don't even know where those vectors are. So giving them coordinates, I could make it up. I could say they're all at the origin. And that would work. But we're not talking about the algebra parts. What we're going to do, and the best analogy for this is copy-paste. I'm going to copy the vectors together, and I'm going to paste them tip to tail. Arrow tip to the tail of the vector. You must never combine them with the same elements together. So the back ends of the arrows never touch, and the tips never touch each other.
So the top of the U.
Yep. So watch. I'm going to add u plus v. So over here, I'm going to come over, and I'm going to say u is, let's see, how tall is u? So it's 1, 2, 3, 4. It's 5 boxes tall. So 1, 2, 3, 4. So that's u. I'm going to add v to that. So I'm just going to take a copy of v. I'm going to copy that. I'm going to paste it over there. So I'm going to draw that. V is 1, 2 blocks over to the right. So there's v. So here's u and v. Listen, the answer to my question, I'm going to start drawing my resulting vector from the very first point that I started with to the end of the last vector that I had. So here's what it does. That is u plus v. So the green is the solution. The whole picture is the work. If I add u plus v together as a force, the resulting force would be going that way. So in other words, if you had 2 people pulling a box in different angles, if one person is pulling it really hard this way, another person is pulling it directly perpendicular to it with that amount of force, with just a little bit of the original force, then the box would end up going like this. Right? So I'm pulling it that way, and somebody else is pulling it to the right, just barely. It would trail off to the right side as I'm going. In fact, it would follow this pattern that you see here. That's exactly what we're going to talk about. What if 2 people are pulling something in 2 separate angles? What if there's a gigantic box in the middle, it's super heavy, and 2 people strap cords to it. One person's pulling it like 60 degrees on this side, the other person's pulling it at maybe 80 degrees on this side, and they both pull it at exactly the same amount of force. Well, because the angles aren't the same, it's not going to go straight like they wanted it to. It's going to go to one side or the other. If one person's pulling it a stronger force, it's going to go towards that side. But the other person's affecting it as well, so it's going to kind of go backwards one way. And so, let me just do one more thing, and we'll be almost done. Let's do something different. Let's do 3v minus u plus w.
So what would the answer be?
The answer is a drawing.
So that's the answer.
The green is the answer. Shh. Now I could ask you, what is the resultant's direction and magnitude? And you would have to find out the direction and magnitude of what you get left. But on these, when I ask you to do this on an assessment, I'm going to ask you, I'm going to give you grid paper like this. I'm going to ask you to draw it for me. Yes, yes. And so we're running out of time, so I'm going to kind of go ahead and give you a minute or two to look at it. But you're going to be taking these vectors and putting them together. What does 3v mean? Take v, put 3 of them back to back to back. What is minus u going to do?
Make it go back.
You're going to flip u around. So really, u, negative u, would be upside down. So the tip would be at the opposite side. So instead of going up, negative u goes down. When I put a negative sign in front of a vector, the only thing it does is it makes it go in the opposite direction. So it's literally a 180-degree turn. So draw this for me real quick. See if you can get that. Last step. 3v. I'm going to take the vector v, right? That vector v is here. I'm going to draw it 3 times. So v is 2. It's just 2 boxes. So we're going to go, we'll start at that point. So you're going to go 1, 2, 3. So there's 3 v's put together. The next part is negative u. So I'm going to go down, straight down, vertically down 5 boxes. So 1, 2, 3, 4, 5. So it's going to go down like that. And then plus w. So I'm going to take that vector w and put down here and go up diagonally. Now, the resulting vector will go from the starting point to the terminal point. It's going to go right through my other vectors, but that's okay, right? This is where I started. That's where I ended, right? Draw an arrow to it. That red is the answer. Okay? Don't worry, the blue part is just how you get there. It could go around in circles and underline and it could do all kinds of stuff. You're still going to go from start to finish to get your results. Hold on. Homework. Page 464. Page 464. It's 2 through 20 even. Take this time. Go home, practice this. This is not something that's just going to automatically click.